happening? Okay. So this nested loop section is a couple of interactive examples that I wanted to use to try to make more clear what's happening with a nested loop. But the basic idea of a nested loop is to create a grid. And there's actually a couple good examples of this in some of the homework assignments from last week. We can actually just take a quick look at those. Let's see. So this is an example of one that I think Leonardo did. And this is basically, he created a nested loop for this one. So you can see there's not just rows like in the loops that we created the last couple of weeks, but there's also columns. And so that's basically the point. If you want to be able to create a grid, it's helpful to use a loop inside of another loop. So that's what nested means. It means something that's inside of something else. You can think of like a nest has eggs inside of it. So a nested loop is one loop that's inside of another loop. And we'll look at a simple example of this today, and then we'll look at some more complex versions on Wednesday. But you can have as many loops inside of other loops as just like you can have multiple if statements and other things like that. But you just have to be careful of naming your variables and closing your loops and all that stuff. So that was one example, and then there's another one, I think, a cell that you did. Yeah, so this is a good example of a grid pattern. But instead of using a nested loop, you just created the each one of the rectangles for each column or for each row. So the columns are a loop, like the columns meaning the horizontal divisions, but then the rows you wrote in each rectangle. So it's kind of like what we talked about when we first went over a loop. How do I repeat something? So you basically want to repeat this part inside of the loop that you already have. And so that's what we're going to look at how to do today. So I have a couple of visualizations to look at, and then we'll write some code. Because I think it can be hard to sort of visualize what's happening with a nested loop. So in this code, we have basically what we wrote last week with our loop. We start with x equals 0, and then we keep going until as long as x is less than or equal to width. And then we increment x by 100 each time. And put on the slides. So that's what we did last week, and we could draw our ellipses across the screen. We can look at our example from last week real quick. So we can draw our circles, and these are my like little self-portrait guys, but we're essentially seeing x equals 60, x is less than or equal to width, x plus equals, 120. So with the nested for loop, for each x, we then go and do a loop for y, and that's how we create the grid. So remember that each loop is looping, so when we loop inside of a loop, we do it multiple times. So I set this up so that you can see each time. So the first iteration of the loop, x is starting at 0 here. For some reason, this is offset. But you can see x is starting at 0 up here, and y is starting at 0 here. So when we go through this loop, the first time it draws an ellipse is inside of the y loop. And so then when we loop through the y loop, so we draw our first ellipse, and then we say y plus equals 100. So the next thing that we draw is a circle at x is 0, y is 100. So with our nested loop, the y loop is incremented, but we keep looping until we get to the end before we go back to the x loop. So the x is still 0. The x hasn't looped yet. So we can loop again. So we do y plus equals 100 again. Down here we get x is still 0, y is 200. Loop one more time, x is still 0, y is 300. Now y is going to be greater than height in our next version of the y loop. So the y loop ends, but we're still inside of the x loop, so we go back to the x loop, and then we start the y loop all over again. So now we're going to say x plus equals 100. So we see x is 100. But now we start the y loop all over again, and we do the whole thing again with this new x value. So now y is 0, and we add 100 to y, add 100 to y, add 100 to y. So we're doing two loops. One is looping across the columns, and one is looping down the rows. And every time we go to a new column, we redo all of our rows. And that's how we get this nice grid of each one of, across and down our canvas. So it's a little bit complicated, but it's a easy way to create a grid in our sketch. What was I going to say? Oh, so you can, I'm doing X and then Y, but you could also start with Y and then do X. It doesn't really matter which one is nested in the other one, as long as you're repeating them both. So we can isolate some of the individual parameters here. The highlighting is a little goofy here. Let's go back to the, this probably looks weird because I usually work on a Mac, and it looks like the font is kind of weird on this one. Let me check. I feel like I fixed this, but it's not. So it looks a little goofy, but you can see the main numbers. So X starts at 0 here, and if I change this number, you can see the beginning part of our grid moves back and forth. So it's just like our regular loop. The X part is the starting of the left-hand column. So it can go negative, it can go positive. Usually you want it like somewhere like that or like that, so the grid fills the space. So usually be around 0. Then the value over here is how wide the grid goes. So it doesn't actually have to go all the way across, but you can decide. Usually you probably want it to go all the way across, but it doesn't necessarily have to. And then the last number in your loop is how far it goes between columns. And so it's pretty much the same thing with the Y, where we can change the starting point of the grid, can change the distance or height of the grid, and then the space in between the columns. So then within each column, and this is where we're going to do more design stuff on Wednesday, now we have this ellipse, and again, the numbers are kind of weird looking on here. I'll try to fix this later. But you can see this green circle is like each point, each XY in the grid. And normally if we want to show the grid, we would have our shapes aligned to where it is in the grid, but you don't necessarily need to. So I can increment where X is and move X inside of this sort of like cell that's created. And we can also change the shape of what's in there. So it's almost like we have, a whole like table of new little canvases where we can design a repeating pattern. So let's actually draw this now. And the other thing I want to do is I'm going to show a couple different ways to do this. So it's a little bit more technical today, and then on Wednesday we'll focus on more design stuff. So let's actually draw the code for this, write the code for this. And I'm going to do two different versions. I'm going to do one using XY, and I'm going to do one using transformation. So let's put XY here. And I'll try to talk about the difference. Okay, so I'm going to make a comment here. And this is our nested loop grid example using XY. And I'll put the date. And I'm just going to use the draw function for this. We're not going to add any variations for now. We're just going to create this. And if you want to add variations later, you can add in randomness and other stuff. And you can either use no loop or change the name of the function if you want to do that. So let's start with our first loop. So we'll start with 4, and I'm going to start with X just to stay consistent. So we're going to start with let X equal 0. So we're starting at the left side of the canvas. X is less than or equal to width. going all the way to the right side of the canvas, and then we'll do x plus equals 100. So the same basic loop that we wrote last week. So then I'll write an ellipse, I'll put it at x, and middle of the canvas 200, and the size is 50. And there we have our basic pattern. So now I'm going to draw the same for loop, but I'm going to use y, and then I'm going to put them together. So if I do everything the same except replacing y and width, or x and width with y and height, so I'll say for let y equals 0, y is less than or equal to height, and y plus equals 100. And I draw an ellipse at, so I don't have x here, I just have y. So the x, I'll do the middle of the canvas is 200, and now I have y, and I'll do 50 again. So now I have my rows, right? The first one with the x's draws a circle at each one of my columns. The second one with my y's draws a circle in each row. And so what I want with my nested for loop is to put one loop inside of the other. So I'll just take out this ellipse here and grab this y loop. I'll just cut and paste, and I'll go ahead and tidy the code to format. Now I have x and y, so I just replace x with y. And so now I have my full grid. And so part of the reason this works is because my circle is drawing from the middle. So if I start at 0, 0, the circle is lined up with the top left corner. And since I'm adding 100 each time, and my canvas is 400 by 400, so it's evenly divisible, so it looks like it fills out the whole canvas, right? If it was a different number, like if it was like 80 or something like that, or let's do 75. So now it doesn't quite align with the canvas. So 100 works there because I'm just doing something that's a quarter of the width of the canvas. So you might want to use variables here, like you could say width over 2 to have 2 columns, or width over 4 to have 4 columns, width over 8. So you can use variables in this section as well for how many columns you want. And a formula for that, normally what you would see, what I would write is like let col or cols for columns equals 8 if I want 8 columns. And so then I can divide width by the number of columns I want, and that will give me my columns. Although I actually have 9 columns because I'm starting on 0, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. And so that's because I'm starting on 0 and I'm using less than or equal to. So if I change this a little bit, like if I start at 50 and I only go to less than, now I'll have 8 columns. 1, 2, 3, 4, 5, 6, 7. Oh, now I have 7. How did I do that? 1, 2, 3, 4, 5, 6, 7. I guess I need to, yeah. Let's start at like, even if I start at like 1. 1, 2, 3, 4, 5, 6, 7, 8. There we go. So now I have 8 columns. What happens if I start at 0, but I do less than? Okay, then I still have 8 columns. 1, 2, 3, 4, 5, 6, 7, 8. So there's a few different ways to do it. I could also start at, well, what I probably want to start at is half a column. So let's make another value that's like W for the width of a column. And we'll call that width divided by cols. So that'll be a little bit easier to write. So I'll go plus equals W, and then I'll do half a column for X. Okay, there we go. So now it's balanced. So I have 1, 2, 3, 4, 5, 6, 7, 8 columns. So I'm just using the width of the canvas here so that my drawing will update. You don't have to do it this way. Obviously, it's a little bit more complicated, but it's an easy way to use math to make sure that your design always matches the canvas. So if I make the canvas really wide, my design changes with the canvas. If I make the canvas really skinny, my design changes with the canvas. So it's same as everything we've done so far in the semester. If I'm using variables instead of hard-coded numbers, then my design will update with different sizes, different resolutions. So then if I want to do the same thing with the y, it's exactly the same thing. So I can say let rows equals 8, and let h for the height of a row equals height divided by rows. So then I want to start at h over 2, and I want to go to less than height. And now I can say y plus equals h. So now I can fill in my grid really nicely, and I can make simple changes to my code. Like if I want 2 columns instead of 8, I just change that number and everything else updates with it. Same thing with my rows. Let's say I want 4 rows instead of 8, or if I want 6 columns and 4 rows, it'll fill that in. And then the same thing here, if I want to change like the height of my canvas, if I want to change the width of my canvas, my design is going to update to match the numbers that I put in. So as we kind of talked about in a lot of different examples throughout the semester, using these variables makes my design more adaptable than if I'm just writing the individual numbers. And then I also now know the width and height of the cells that I'm using, so I can use that instead of the 50 for the shape of my circle. So I can fill in that space with my circle. So if I want the circles to be the same, I can do 6 by 6. If I do 6 by 8, then they're going to get wider. If I do 6 by 10. So my design will update with the width and height that I'm using. So that's like one basic way to approach it, using a lot of variables, doing a lot of the math that we need to do through those basic variables. There's another approach that's more conducive to like not really thinking that much about like the proportions and the variables that I want to show next. But before we move on, any questions about what we've got here? All right, so another way to do this where we don't really have to think about X and Y and all this stuff as much is by using the transformation stuff that we looked at a couple weeks ago. So I'm going to save this example and make a new file. I'll make a new tab unless I want to come back to this one. So I'll call this nested loop example transformation. And I'll start with a comment. Nested loop / grid using transformation. And so you don't actually have to, you don't necessarily need to use these techniques separately, but they work well. They do work well together, but they're kind of like different approaches to thinking about the numbers. Okay, so for this one, I'll start with the same nested loop, but I'm going to change something. So I'm going to start with for let x equals 0, x is less than width, x plus equals 100. And I'm going to draw my ellipse again. And in the past, what I've done is I've said ellipse at x, 200 for the y and 50 for the size. And so we get this little grid of ellipses. Let's start at 50 so it fits. So then at our nested loop, we go for let y equals 50, y is less than height, y plus equals 100. And we move our ellipse inside of the y loop. So that's our nested, whoops, just rewrite it, ellipse. Now we have ellipse at x, y, 50. And so now we have this grid again. But now, if I want to make changes to this, I always have to be making changes relative to x and y. So actually, let's go back because I'm going to change this eventually. So for this one, let's say I want to implement my self-portrait. I could just grab my self-portrait function. That'd probably be easier. But let's say I forgot where that was or something like that. Then I might want to, let's say this is the face of the self-portrait. I'm just going to make a really simple one. So let's turn off the stroke. And let's actually do a few less rows. So if I wanted to add the eyes of my self-portrait, so let's do fill is black, and I'll add an eye. So I can't just be like, the eye is, 10 over and 20 and, whatever. I have to do everything relative to the values that I'm using for the face. So if I just say x, y, let's say width over 2, height over 2, I have to put a fill here. Fill is white. So I have to move the eye over, right? If I want to move it over, I have to say x plus, 10 or something like that. And then if I want to make the other eye, I have to copy this and say x minus 10. And then I've got the two eyes. And if I want to move them up, I have to say like y minus 10 and y minus 10. And so that looks okay. But let's say I decided to change things, right? I want to make it bigger, so I'm going to make the width 600. And I want to make it smaller here, so let's make the height like 100. So it's kind of hard to tell, but the eyes aren't matching exactly the way that the face is changing. Let me make it a little more obvious by making the eyes smaller. So I'll make the eyes 10 by 10. So I'll just use 10 hard-coded here for every value here. Okay. Oh, something weird is happening. I think I changed the insert mode. I didn't know that was possible. I'm just going to refresh. Okay. So here's my self-portrait with the small eyes. Okay, so if I change the number of columns and the number of rows, the face changes size, but the eyes are still tiny, right? Because these 10s aren't relative to the size of the face. So I need to keep those variables in mind. So instead of using 10, I need to use something that's relative to how big I want the face to be. So in this case, I don't actually know what W is here. So let's print it out. I'll console.log WH. So it's 60-ish. And so, but I don't actually, so 10, so it's about a sixth of the size of the face. So I could capture that using, width over 6. So I could say like let eye size equals width divided by 6. So close enough. And then I can, put that in for all of my 10s. Oops. It's kind of a big variable. Let's just use ES for eye size so it won't take up so much space. Okay, so now if I change the number of columns, now the eyes change with the rest of the face, right? Everything is relative to these variables. So that's one thing I want to make sure I'm doing if I'm using this approach. And you can do it with the other approach. But with the position, not so much with the size, but mainly with the position, if we use transformations, then we don't actually have to worry about making everything relative to x, because what we're going to do instead is translate to xy and then just start drawing there. So that's something that we can do with our transformation. So instead of drawing my ellipse right here, what I'm going to do instead, if I draw my ellipse at 0, 0, then to start, all of the ellipses are going to be up here in the top left, because that's where 0, 0 is. But if I use transform, I can translate to xy, and then my ellipse will be drawing at different places, but I'm doing multiple transformations here because each time I go through my loop, I'm translating. So you can see it's getting, we only see 2 ellipses, it's getting off really quick. What I need to do first is push the basic transformation matrix, do my translation, draw what I want, and then pop my transformation matrix. So when I go back to the beginning of the loop, now I don't have to worry about where xy is. I'm just translating to xy. So now I can draw my face. Here's my ellipse. I'm going to say no stroke. And let's say fill is white. So here's my face ellipse, and then let's fill black. My eye ellipse. So now I don't have to say x plus equals whatever. I can just say it's at 20, and the y is at -10. So it's relative to the center of each circle. So I can go negative for the y, and the size of the ellipse is, let's just say 10. And so for the other eye, I can do -20 on x. So again, it's relative. The xy is moving across the canvas. So I can say -20, -10, and 10. And I'll get the same basic result, although I'm a little bit off with this 20. So this isn't scalable. I can't change this. Like if I go up here and I change, x to 200, oops. Oh no. Something weird is happening where my cursor is changing to an insert instead of a regular cursor. Let's see what happens. Okay. So as I mentioned, none of this is relative to the setup of the design. All of these numbers are hard coded. So if you want a design that changes when you change the size of the canvas or change the size, the number of rows or columns, then it's better to go with this approach where everything is relative here. But if you don't really care about that and you just want to make a grid and it's always going to be the same size and you just want to deal with numbers inside of the grid, another way to do that is to use push and pop and translate. And then the other thing that's nice here is you can do rotation. So let's say, I want to rotate my my self-portrait. I can also rotate, pi over 2 or something like that. And so now I can rotate really easily because I'm translating to different places. So all of the advantages of transformation in a basic canvas setting are now possible within this grid or this nested loop. So those are a few different, so that's the basic difference between these two different approaches. And as I mentioned, you can combine them. You don't necessarily need to use one or the other. Like I can actually have, let's say I wanted to put something behind this. I could do a rectangle. Let's do rect mode center. I could put a rectangle at XY and 100, 100. I don't have the width and height here. And let's do a random fill. So there's actually a reason for this to be here. So let's say fill. I'll just put the random directly in here. Random 255, 255, random 255. Oh, I still have the loop on. Let's put no loop down here. So I can still use the XY with my shapes and then do push and pop. Like it's not necessary for me to think of these two approaches as like essentially separate from each other. They can be combined. But it's just two different ways of thinking about these different sort of like cells in our grid as we're designing this pattern. The advantage of the transformation is that I can draw everything with like this origin 0, 0 changing as I go throughout the cells of the grid. And so I don't have to worry about like X and Y doing that mathematics. And I can also use transformations like rotation or skew or scale or things like that. Like, maybe I could rotate, since I'm doing some randomness now, I could rotate a random value. Let's do 2 pi actually, since that's a full circle. So that's kind of a cool variation. I can rotate each one of my self-portraits a random number. So it gives me a little bit more flexibility in terms of things that I can work with. So yeah, those are the two approaches that I wanted to cover. As I mentioned, we're going to go over more about doing actual design within this grid setup, but I just wanted to go over the basics and give you guys some time to play around with it today. Let's see. So yeah, on Wednesday, we'll go over this section on just like making patterns. There's some more details about making choices and randomizing stuff. And then the assignment for this week is just a generated pattern that uses the nested for loop. So it's kind of combining what we've done so far with the extra layer of rows along with columns. So basically just, really essentially it's just like adding a nested for loop in there. So you can continue working with the design that you already started, or you can start something new, whatever you feel inspired to do. The assignment for assignment 9 is due Wednesday. So if you're still working on that, obviously you can work on that tonight. If you finish this and you want to start on the next assignment, that's this assignment 10, which is using the nested for loop. Let's see if there's anything. I think that's basically it. So if you guys have any questions, let me know and I will check things out. I'm going to stop this.